This is Earth. This is the Sun. The Sun could fit more than 1 million Earths inside it. Now hold that image in your mind, because in the next few minutes, I am going to show you something so large that the Sun, our solar system, and even the Milky Way will look like nothing beside it. We are going to climb the scale of the universe, one step at a time. Each step will make the last one feel small, and by the end of this journey, you will not look at the night sky the same way again. Let us begin where you are right now. Earth. A pale blue world about 12,700 kilometers across. Home to every story ever told, every ocean ever crossed, every person you have ever loved. It feels enormous when you stand on it. But the moment we step outward, it begins to shrink. Here is Jupiter, a planet so massive that more than 1,300 Earths could be packed inside it. Its great red spot, that swirling storm in its southern hemisphere, is itself wider than our entire planet. And yet Jupiter is just a beginning, because Jupiter, for all its size, is nothing next to the Sun. Our star is so enormous it holds 99% of all the mass in the solar system. Every planet, every moon, every asteroid combined is barely a rounding error beside it. And the Sun, this giant that warms our world from 150 million kilometers away, is, on the cosmic scale, an average star. A small one even. So let us see what large really means. Meet UY Scuti, a red supergiant glowing roughly 9,500 light-years from Earth. It is one of the largest known stars in our galaxy. If you placed UY Scuti where the Sun is, its surface would swallow Mercury, Venus, Earth, Mars, and reach far beyond Jupiter. Light, traveling at 300,000 kilometers per second, would take more than 7 hours just to cross its diameter. And yet, even UY Scuti has a rival. Stephenson 2-18, a star so vast that some measurements suggest it could engulf the orbit of Saturn. Astronomers still debate its exact size because, at these scales, the edges of stars are not sharp lines, but glowing, uncertain fog. But if those measurements hold, Stephenson 2-18 is one of the largest stars ever discovered. You might think this is the top of the ladder. It is not. We are only getting started. Because stars, for all their size, are still just points of light. There is something out there that does not shine at all, yet dwarfs even the largest known star. It is not a planet, it is not a star. It is a wound in space-time itself. A supermassive black hole. At the heart of a distant galaxy, 10 billion light-years away, lies an object called TON 618. Its event horizon, the boundary beyond which nothing escapes, is estimated to be over 1,300 astronomical units across. That means if TON 618 sat where our Sun is, its darkness would extend more than 40 times farther than Neptune. Our entire solar system, every planet, every probe humanity has ever launched, would vanish inside it without a trace. TON 618 is one of the most massive black holes ever discovered, and still it is barely a speck of what is coming, because so far we have only been measuring objects, single things. To understand true scale, we have to zoom out, far out. Here is our solar system. 8 planets, countless smaller worlds, all bound to one quiet yellow star. From edge to edge, it stretches across light hours. The Voyager probes, launched in the 1970s, are still traveling outward, and after nearly 5 decades, they have barely begun to leave it. Now zoom out farther. Our Sun is one star among an estimated 200 to 400 billion others, all bound together in a slow, spinning spiral of light and gas and dust. This is the Milky Way, 100,000 light-years across. So large that if you tried to send a radio signal from one side to the other, it would not arrive until long after every empire on Earth had crumbled to dust. And the Milky Way is one of many. 2.5 million light-years away, drifting toward us at over 100 kilometers per second, is Andromeda, our nearest large galactic neighbor, wider than the Milky Way and bound to us by gravity. In about 4 billion years, the two will collide and merge into something new. But even Andromeda and the Milky Way together are tiny. Because they belong to a gathering of more than 80 galaxies known as the Local Group, a small island of light in an ocean of dark. And that island, vast as it is, sits on the edge of something far larger. This is where the scale begins to break the mind. Zoom out farther, and our local group becomes a single thread inside a flowing river of galaxies called the Laniakea Supercluster, roughly 500 million light-years across, containing the mass of around 100,000 trillion suns. Inside Laniakea, entire galaxy clusters flow toward a mysterious gravitational anchor known as the Great Attractor, a region so massive and so distant that we still cannot fully see it. You would think nothing could be larger. A supercluster of 100,000 trillion suns. And yet what comes next is so enormous that astronomers still argue about whether our universe should even allow it to exist. Because beyond Laniakea, stretched across the deepest reaches of the observable universe, lies a structure that should not be there. It is called the Hercules-Corona Borealis Great Wall, a vast filament of galaxies, of light, of matter, woven together by gravity over billions of years. Its size is almost impossible to write into a single sentence. By current estimates, it stretches roughly 10 billion light-years from end to end. 10 billion light-years. Light, the fastest thing in existence, would need 10 billion years to cross it. That is nearly the entire age of the universe. If a photon left one side when the cosmos was still young, it would still be traveling now, and it would not arrive for billions of years to come. The Hercules-Corona Borealis Great Wall is one of the largest known structures in the observable universe. And here's the strangest part. According to the cosmological principle, the idea that on the largest scales the universe should look smooth and even, a structure this big should not exist. It challenges our models. It whispers that the universe may be stranger, older, or more connected than we understand. Some astronomers debate its boundaries. Some question whether it is truly a single structure. But whatever it is so vast that every star, every planet, every black hole, every supercluster we have visited in this journey could fit inside it many times over. This is, as far as we currently know, the largest thing in the universe. And here is where the journey ends, but the wonder does not. You are one human, on one planet, orbiting one ordinary star, in one arm of one galaxy, inside one tiny group of galaxies, on the edge of one supercluster, drifting somewhere inside a wall of light so wide that the universe itself can barely contain it. And yet, somehow, you exist. You are aware. You are looking up. You are asking the question. That is not insignificance. That is something stranger and more beautiful. The cosmos built atoms, and those atoms built you. And now those atoms are looking back at the cosmos and understanding it. If this journey through scale made you see the universe differently, subscribe to the Cosmic Scale because this is only the beginning. There are stranger places out there. Older things, emptier voids, objects we are only just learning to see. The universe is bigger than you can imagine, and we have barely started looking.